Welcome to the Cardinality of Reality with Keith.ai, where we explore how infinity shapes our universe. Let's jump into the infinite. The mathematics of infinity might just be the key to unlocking the biggest mysteries in physics, from the tiniest quantum particles to the expansion of our entire universe. And today, we're going to show you how these seemingly unrelated scales are actually connected through something mind-bending.
Well, that's quite a statement to wrap our heads around. You're telling me infinity can explain both the quantum world and the cosmos?
Exactly, and it all starts with this fascinating split that's been driving physicists crazy for nearly a century. On one side, we've got quantum mechanics telling us there are fundamental limits to what we can measure at the atomic scale.
You mean like Heisenberg's uncertainty principle, where you can't know both position and momentum at the same time?
Precisely, and this isn't just some limitation of our measuring devices. It's woven into the fabric of reality itself. Heisenberg's uncertainty principle tells us that the more precisely we measure a particle's position, the more uncertain its momentum becomes, and vice versa. We capture this mathematically as delta x, delta p, greater than or equal to h bar divided by 2, where h bar is Planck's constant. But here's the revolutionary part. What if this isn't just some arbitrary rule of quantum mechanics? What if it's mathematically necessary because we're trying to map between continuous and discrete descriptions of reality?
And then on the complete opposite end of the scale?
We've got this profound mystery called dark energy, pushing our universe apart at an accelerating rate. It makes up about 68% of our universe's energy content, but its strength is bizarrely small, about 10 to the power of negative 120 in Planck units. This value is so precisely tiny that if it were just slightly different, our universe as we know it couldn't exist. This cosmological constant problem has puzzled physicists for decades.
So how does infinity connect these two completely different phenomena?
Well, it goes back to this brilliant and slightly tragic mathematician named Georg Cantor. In the 1800s, he proved something that literally drove him to the edge of sanity. There isn't just one size of infinity. There are actually different sizes, each bigger than the last.
Oh, come on. How can something endless be bigger than something else that's endless? It doesn't make any sense.
Think about it this way. Imagine counting numbers forever. 1, 2, 3, and so on. That's one kind of infinity. But now, think about all the possible points on a line. Between any two numbers, there are infinitely many more numbers. That's actually a bigger infinity.
You know, my brain hurts just thinking about that, but I'm starting to see where this is going. There's some kind of tension between these different infinities?
Exactly. And here's where it gets really interesting. Whenever nature has to bridge these different types of infinity, like when we measure quantum systems or when space processes information, this tension shows up as a mathematical constant called kappa.
So this kappa thing, it's like some kind of universal compression ratio.
Precisely. Just like when you compress a digital photo and lose some information, reality can't perfectly translate between these different types of infinity. That's what creates quantum uncertainty at small scales.
And somehow this same principle explains dark energy? That seems like quite a leap.
But that's the beauty of it. When you do the math, this same tension accumulates across vast distances and naturally produces exactly the amount of dark energy we observe. No fine-tuning required. The logarithmic compression between infinite cardinalities gives us that mysterious 10 to the power of negative 120 value automatically.
Well, hold on. Are you saying we can actually test this theory?
Yes, the framework makes very specific predictions about quantum interference patterns, gravitational waves, and the cosmic microwave background. We're talking about subtle effects, 1 part in a million to 1 part in 1,000, but they're within reach of next-generation experiments.
So if this is confirmed, it would be like, what? The biggest breakthrough since Einstein showed space and time were the same thing.
Even bigger in some ways. It would show that quantum uncertainty and cosmic acceleration aren't just random features of our universe. They're mathematical necessities that emerge whenever reality deals with different types of infinity.
That really puts a new perspective on both the very small and the very large, like they're two sides of the same cosmic coin.
And you know what's really exciting? This research is just beginning. We're right at the start of understanding how infinity shapes everything from quantum foam to the cosmic web.
Though maybe we should warn our listeners not to think about it too hard. Remember what happened to poor Cantor.
Well, here's a gentler way to think about it. Next time you look up at the stars, remember that the same mathematical principles governing those vast cosmic spaces are at work in every atom of your body. It's all one elegant story, written in the language of infinity. You've been listening to the Cardinality of Reality. Find more mind-bending mathematics and physics at keith.ai. Until next time, keep counting those infinities.